Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous video, we saw that sample selection bias can distort our estimates. But here's a question worth asking before we panic. Does non-random sampling always cause bias? And the answer to that is no. Not always. And understanding when it does and when it doesn't is one of the most important distinctions that we'll make in this video. There are three types of selection. We have selections along an irrelevant dimension. Then selection along the x. And ultimately, selection along y. These three cases look similar on the surface, but they have completely different consequences for our estimates. For instance, if we look at case 1, selection on an irrelevant dimension. Suppose we're studying the effect of firm size on profitability. And we conduct a telephone survey, say we call on a Tuesday afternoon where people are more likely to answer. Now, does this create a bias? The answer should be no, because Tuesdays firms are not systematically any different from any other day of the week in terms of size or profitability. Okay, so the selection in this case is non-random, but it's along a dimension that really has nothing to do with our model because it doesn't really affect your firm size or profitability for that matter. Which means that in this case, we keep that assumption 5 of OLS, meaning the conditional expectation of the error term in sample to be 0. Okay, so the error term is still mean 0 within this selected sample. And OLS will be unbiased. Now, this is reassuring because what that means is non-random sampling only causes problems when the selection mechanism is related to the variables in your model, which means that sometimes if you're worried that you actually have non-random selection, then if you make sure that it's not affecting any of the variables in your model, you're good to go. If we look at case 2, where we have selection on X, suppose that larger firms are more likely to answer that call. And then also imagine the complete extreme. A firm only appears in the sample if the firm size is bigger than a benchmark firm size. So what we're saying in here is something along those lines. Imagine that initially you have your sample. Like this is your entire sample. And let's say your fitted line would have looked something like this. And as we said, we're looking at a threshold in here where we believe that a firm only appears if the sample size or a particular dimension here along this x variable of interest, the threshold being this x star in here, So nothing below this side appears, which means that all of these observations that we have in here, they are now not part of our sample. So this is all that is remaining for us. Does this create a bias? And you'll notice that we haven't really changed anything in the way that all of these observations are situated on this higher part. So we're not really we don't really have to change the actual fitted line that we have here. So the sample is not random, that's true, but within the selected sample, the error term is still uncorrelated, in this case, let's say with firm size, which means that the OLS can still recovers the unbiased estimate. Okay? For this particular case in this relationship. And it does so using only the selected range of firms. So this is also what we call an exogenous selection case. Okay? The selection rule depends on X, which is in the model, but not on the error term. So the key OLS assumption that we've been looking, assumption 5, that the conditional expectation on X is equal to 0, it's still going to hold within the selected sample. And finally, case 3, where we're looking on the selection on Y. Things are going to switch around here because we are no longer looking at like a selection based on our X dimension, but we're looking on a selection based on the Y dimension. So if I have an initial sample, let's say that looks like this, and I can clearly see that the fitted line would be somewhere like this. Now, what I am selecting is anything that is above a certain profit level or a certain Y threshold in here. So let's say I'm not going to select any of the variables beyond this level right here. So that means that anything that I am looking above here, it's going to disappear. Okay. In this particular case, we'll see that bias is created, and this is like the damaging case. Within the selected sample, now the error term is no longer mean 0. Okay, so among the firms with low profits that still made it into the sample, those must have had unusually positive errors to exceed basically the threshold. And among firms with high profits, the errors can be anywhere. In other words, what is going to happen in this graph in here is that this fitted line will no longer be applicable in here. And it's pretty clear that a line that maybe looks more like this would be a better fit. Okay, so what that means is that ultimately our OLS estimation in here is biased. So the conditional expectation of the error on X is ultimately not equal to 0. Okay, this we call also an endogenous selection. So to summarize overall, we have 3 different types of selections. Among the 3 of them, the first, where we have along an irrelevant dimension, and the second, a selection along the X, they do not create any bias for us. However, the one that is along the Y, this is where we had a problem, and we finally have biased estimates. Now, If we were to look at another example, for instance, think about hedge fund returns. So let's stick to the finance exercises that we've seen so far. Funds that survive long enough to report, let's say, their 10-year of returns are by definition the ones that did well. So estimating average hedge fund performance from survivors will dramatically overestate or overestimate true returns. This is also, for those of you who do finance, the classic survivorship bias example. So we've now seen the distinction intuitively and graphically, but why exactly does selection on Y create a correlation between X and the error term, or how does that bias work mechanically? That's exactly what the path diagram in the next video will show us. So stay tuned and I'll see you in the next video.